Hello everyone, welcome to AWS Tutorials. In AWS Tutorials, we provide workshops and exercises to learn about AWS services. These workshops and tutorials are uploaded to our website aws-dojo.com. Today, we are going to talk about integration of AWS IoT Core and Amazon Timestream. Amazon Timestream is a database for time series data, and it has been made generally available, I think, a couple of weeks back, if I'm not wrong. And today I'm going to talk about how this database can work with IoT Core and what kind of value it brings to the table. So let's get started. So first thing, I would like to spend some time talking about AWS IoT Core, but again, I don't want to focus on this topic here because that's not what the purpose is. Purpose is more for the integration, but I want to give you a small introduction. There is a separate video which talks about the whole AWS IoT Core device to core communication. I am going to provide you a URL of that video in the description box below. Yeah, you can use that to learn about that communication. But just to give you introduction, so suppose if you have a device like a sensor, which you want to configure and you want to create a two-way communication with your AWS IoT Core, first thing you have to do is you have to register your device as an IoT thing inside AWS IoT Core. And then when you register a device, you as a thing, you have to generate a certificate for the device. And this is a X509 certificate, which is generated. And this certificate is then associated with an IoT policy. So basically what happens is that the device uses this certificate for authentication and to talk to AWS IoT Core. And this policy associated with the certificate actually authorizes what kind of performance this device can perform. Okay, so you register your device thing, then you generate a certificate for the thing, and then you also create a policy which authorizes, you create a policy and associate with the certificate, and that way a device gets a certain authorization to perform actions, IoT actions on the core. So once you have this thing configured, actually you can, the device can use MQTT protocol to talk to AWS IoT Core, and then for communication they use the publish subscribe model, and this publish subscribe model works with the topic. So for instance, this IoT Core will have some topic, and then device will have its own topics. So if device wants to talk to IoT Core, it will publish the message to IoT topic, and then IoT Core will have put subscription on this IoT topic, and then by virtue of that subscription, they will come to know what message has been communicated to them from the device. Similarly, if the IoT Core has to talk to device, they can publish a message to device topic, and then device will, on the device side, you will have some code written, some script written, which is subscribing to this device topic, and by virtue of that subscription, device will come to know what message the IoT Core has communicated to the device. And this way, using this publish subscribe based model, using the topics and using the MQTT protocol, device and IoT Core communication happens. Now, once a message comes to IoT Core, you might want to handle the message to create some business scenario, some workflow, probably storing the data or doing some kind of analytics on top of data, or you want to run some business logic to make an API call. Those kind of things you want to do with the message. And in order to handle that, you have to deploy a configure IoT rule. Actually, IoT rule is a configuration where the IoT rules checks for the messages coming into certain IoT topics. And then you can either, based on the either full message or a particular type of message, you can define different type of rules to perform actions. So you might want to say, hey, if any message comes to IoT Core, you you want to take certain action, or if a message comes to IoT Core and that message has certain types of values, then you want to perform some kind of action. So those kind of rules you can define into IoT rule. So IoT rule will look into the message, and if appropriate message has come, it can call one or more action. An action could be as simple as storing it into a database, to making an API call, or passing it to a Lambda function, pass the message to a Lambda function, or put into a queue. Literally, you can do so many things, and there are many out-of-box IoT action which you can configure in IoT Core, or you can also write your own custom business logic using Lambda function. So that's how your IoT Core communication happens. Just to set up a baseline for this particular tutorial. So now let's focus to the other service which IoT Core will integrate in this workshop, and that is Timestream database. And this service has been made available. It's available for quite some time, but it has been made generally available. I think a couple of weeks back only, and it is a fully managed, purpose-built time series database, and which can be used to store any kind of time series data points, and then you can do analysis on the time series data, those time series data. Now, a few things which is important to know from this database point of view is, one, it is serverless. That means you don't need to worry about sizing information or scalability of the server. You simply go and create a database and table and then simply use it. You really don't care about any kind of infrastructure management behind. The solution supports, this service supports data storage steering, and basically this is a way you can actually optimize your data for the performance and the cost as well. And I will explain this topic later in other slide. But just keep in mind that the service supports data storage steering, whose primary purpose is to do some kind of optimization between performance and the cost. It has a built-in query engine which help you to actually able to query your data. So because when you're storing a time series data, you might want to perform various types of analytics query on your data, and it has built-in query to able to create such analytics operations or queries on your data. It has built-in engine for that. And then, it also has built-in time analytics for the time series kind of database. So the time series kind of data points. So these are some of the very important feature. I mean, to be very honest, the first 2 points are very important. That it is a serverless. That means you have not to worry about any kind of provisioning, and it provides data tiering, data storage tiering to optimize cost and the performance. Now, if you wonder what kind of data is a time series data, there are some examples I want to put over here. So, like for instance, if you're putting a stock price over time. So, for instance, take a stock price of Amazon, which is changing probably every minute, every second, and you want to make one entry that Amazon stock price, this is the price, this is the time, this is the price, this is time. So you record, if you're recording certain measurements with a timestamp. That is a typical example of a time series data. And the example is some kind of IoT sensor which is sending temperature measurement or pressure or humidity or vibration and that kind of information. So again, it's sending that measurement with a timestamp, and the timestamp, your frequency could be millisecond, per minute, per hour. That does not matter as long as you are repeatedly sending that measurement with a timestamp with certain frequency. That's a time series database. Another example is if you're running a EC2 instance, then your CPU utilization, your memory utilization with a time. So in summary, the time series database is a data point of measurements which comes with which is repeatedly published and which comes with its own timestamp. Okay. So just to give an example of some of the time series database data points. Now, let's understand some of the key concept that how this whole time series database look like inside Amazon. And I mean, to be honest, this is a very sleek and simple service, but yet very powerful. I really like it. I played with it sometime, and then I really love this service as a way to store your time series data. So let's understand now the key concept. The first thing is measure. So you're always when you're talking about a time series data, you're always measuring something. I mean, you might be like sending various measures of pressure or temperature or vibration or humidity or memory utilization, CPU utilization, stock prices. Yeah, I mean, it's like you're sending various measures in your time series database, and these times these data or data measures are always associated with a timestamp. Okay, so and that's why it's a time series data, because your data has been captured in a series of time. So you always have a measure with a timestamp. And then here onwards, it started becoming little interesting. So then comes the concept of dimension. So dimension is about, okay, fair enough. So I am doing a pressure measure, I am doing a temperature measure, but I am doing it for what? Okay, so for instance, when talking about early example of when you are measuring the stock prices, you are measuring stock price for a particular stock, like Amazon in this case, or in that case, as an example. So in this case, when I'm trying to measure a temperature or pressure from an IoT device, it is for what? And that's where your dimensions come to picture. So you might be measuring out for a sensor. You might be measuring it for a sensor into a particular factory or in a plant or in a machinery. So dimension is which provides metadata about the measurement. So you're getting a measurements, but this is a measurement of what? And there could be one or more dimension for a measurement. Like in this case, I'm talking about there is a sensor in a factory. But to be honest, I mean, it could be it could be bigger than that. I mean, you can talk about there is a sensor in this machinery, and this machinery is on this site of this factory of this city. Yeah, I mean, literally you can build any level of dimension as you want, but you always have a dimension which is a metadata about the measurement. Okay, and then this whole thing is called a record. So now, I mean, so far we talked about like measurements, timestamp, and dimension. But if you talk from the Timestream database point of view, this whole thing, including your dimensions, your measurements, and your timestamp, all things put together is called one time series record. Okay, and then these records are inside a table. So you can have multiple tables, and each table can have their own set of records, and then each record will have their own dimension, measure, and timestamp. Okay, so all these records are bundled under a table, and then you can have, in fact, more than one table, and that you can put inside a database. So construction-wise, the way you work is that you create a database and you create a table, and then inside those tables, you publish your records, and your records will comprise of your dimensions, your measurements, and your timestamp. As long as you understand these 6 terms, you understand how Timestream works. It's as simple as that. Okay, so hope it is clear. If not, let me know. Okay, so moving on. So just to give an example, okay, here's example. In fact, this is example from the exercise or workshop we are going to do today in aws-dojo.com. So you can see here we're talking about a factory which has a device, and it is sending this measurement value, and here is the measurement name, which is like a temperature, pressure, vibration, things like that. And each of these measurements are coming with a certain timestamp. So you get your timestamp, your measurements, which has a value, a name, and then you have got dimension. This is a record, and this whole thing is inside a table, and then of course table is inside your database. Simple. So how does storage steering works. As I mentioned earlier, the storage steering is a way to optimize your performance and the cost. And yeah, some indentation is not good here, but let me tell you. So first is the storage steering happens in a two way. You can have memory store, you can have magnetic store. So memory store is where, so when the data comes in, it always comes to memory store, and then data stays in the memory store depending on how long the retention period you have defined. So suppose you say that, my retention period in the memory store is 1 day, then for 1 day data will be in the memory store, and then it automatically moves on to the magnetic store. So obviously the cost of storing data inside memory store is higher than cost of storing data inside magnetic store, but memory store is definitely faster. So the way people configure Timestream is that they keep data into memory store till the data is valuable data for no reporting and query purposes. And the moment the data is not useful that much or not in use at all, they simply move that to magnetic store. And now, and this when data moves from memory to magnetic store is depending on the age of the data. So you define a retention period in the memory store. Similarly, you can also define a retention period in the magnetic store, but once a retention period of the data inside magnetic store expires, data gets deleted. Okay, so data is no more available into your database. So it's very simple. It's like S3 tiering, if you are aware of S3 class-based tiering. So data comes to memory store, it remains in the memory store for a certain period of time. During that period of time, you can use your queries and reporting on the data, and since it is in memory, it is very fast. And then after that, the data moves to magnetic store, which is a low-cost storage, and it remains in magnetic storage till the retention period, and after that, the data gets deleted. Because generally what happens, guys, time series data has a value for a time. I mean, you will not like to have like 5 years of time series data kind of thing. Generally, people want to make use of a couple of days, weeks, or month, or even that kind of data for analysis on the time series. Once data becomes old, you want to keep the data from the compliance purposes, but you don't want to really use that for active reporting. And this kind of design perfectly suits there, because then you can keep your data in memory for some time, and after that you can move on to low-cost magnetic storage. Okay. So, having understood the storage steering, why we are talking about Amazon Time Store and IoT Core integration? Why we are talking here, and why a topic on this? Reason is pretty simple, guys. Yeah, IoT Core or IoT devices, they generate time series data, and Amazon Time Series stores and manages time series data. So one is the generator, other is the store or management service. And that's why they need to handshake. They need to come together. So if you are building a solution where you are trying to get data from IoT devices, there's high probability, almost 100%, that your data is a time series data. And in that case, your Amazon time series becomes a very natural choice for storing such a data and use that for reporting purposes. And that's why I'm talking about such integration here. I'm planning to create, in fact, another video at some point of time where I talk about how you can write a custom code to publish data to Timestream. So today in this whole thing, in fact, you don't need to write even a single line of code. All through configuration, you can make IoT Core and time series work each other. But there could be a scenario where you are probably writing some kind of code, and that code publishes time series data. And for that purpose, I will create a separate video which talks about how Timestream data then database can be used to publish code-based time series data into it. Okay, but today we focus on the IoT Core and Timestream integration. So what are we going to build today is pretty straightforward. We'll use an MQTT client simulator to publish messages to AWS IoT Core, and then we'll define IoT Rule, which will take the message defined published to IoT Core over the topic, and then it will simply store that into a Timestream database. Okay, so this is what we are going to build as a scenario, and not a single line of the code will be written when we are building the scenario end to end. So in order to make this run this workshop, we have created a workshop and published to aws-dojo.com. I'm going to show you the steps involved in this workshop and explain you how this whole integration works. And post that, yeah, feel free to run this workshop by your own and yeah, implement the scenario and get a feel about how this integration actually works. So let's go to our website. So this is a website, aws-dojo.com, where we have published this whole workshop to perform the integration. So we have talked about this scenario, and let's click on Start the Workshop link over here, which will open this workshop into a new tab, and it is showing you these 8 steps you have to perform in order to complete the workshop. So all you have to do is simply follow steps one by one, and yeah, follow the instructions, and you will be able to implement the whole thing. So let's start with the prerequisite. Prerequisite is pretty straightforward. You need to have an AWS account, and if you don't have any AWS account, you might want to use this link to create one account. Then we go and create IoT role. And why I'm creating IoT role here? Because what is happening is that when you configure your IoT core to Timestream integration, actually your IoT core is going to call your Timestream service, and this role is going to authorize your IoT core to be able to call Timestream service APIs. Okay, so in order to create this role, we log into AWS account. We are choosing Ireland as a region. Then we go to IAM console and say I want to create a role. We select IoT Core as a service, and then we simply give this role a nice name called Dojo IoT role, and simply we create it. And by default, when you create a role for IoT, it comes with the 3 policies automatically attached to it. But this is not sufficient because we need to call Timestream database. So what we will do that we will modify this role, and we will add one more service to it, which is Amazon Timestream full access. Again, I'm giving a large policy-based access here, but if you are going for any production deployment, you might want to become more specific in terms of what permission you give. But yeah, you need to provide access to Timestream database so that IoT Core can make call to Timestream database APIs to store device messages into the database table. So here my role is ready, and once that is done, we move on to IoT to start registering the device. So in order to register a device, as I mentioned earlier, that the device uses certificate and policies, and certificate for authentication, and certificates then have policies to authorize device to perform certain action. So we start with those kind of configurations. So first we go and say, okay, and go to IoT Core, say I want to create a new policy, and this policy we are giving certain access, and we give it a name called Dojo device policy. And once you have, and in this case, we are giving again a blanket access saying, okay, you can perform all kind of IoT operation on all the operations, on all the resources. But yeah, you can really restrict it to say, hey, you can only publish message to following topic. You can really go and provide that kind of specific policy-based access as well. So once our policy is ready, we say we go to the things, and we are trying to register the thing first. We say, okay, I want to create a device. We give this a device called, say, Dojo device 1, and then we move next. It will say, hey, do you want to create a certificate for device? And then, yeah, in this case, we are going for, okay, let's generate a new certificate for the device. So AWS IoT Core will generate this X509 client certificate for the devices. Yeah, you generate the certificate, then you activate the certificate. And once you have activated the certificate, it says, do you want to attach a policy to certificates? And again, as I mentioned earlier, this policy will authorize device via certificate ability to perform certain action. So we say, okay, fine, we want to attach this policy to the certificate. You attach this policy to the certificate. And then finally you say, okay, let's register the thing. And that's how your device registration is complete. So now in this step, what you have done is that your device has now been registered as a thing inside AWS IoT Core. It had its own certificate, and certificate has a policy attached to it. So it is all good to be able to receive communication. Okay. So what we do next? Now we are going to create some of the backend things. So we will create a Timestream database, which AWS IoT Core will use to publish the device messages. So this is very straightforward, guys. We simply go to Timestream console and say, I want to create a database, and we simply create a standard database, and I'm giving this a name called Dojo database. So once the database has been created, we open the database detail and say, I want to create a table inside the database, and this table, we give it a name, Dojo table. And then at this point of time, it asks for a retention period. That what is the in-memory retention period? What is the magnetic memory retention period? Again, I'm giving it 1 day, because to be honest, for this exercise, I created a database and then I deleted it. But yeah, you can create even hourly or even lower kind of thing. It can go minimum, it can go minimum 1 hour retention as well, and maximum 12 months retention. So literally you can, and like in case of memory store, you can go for 1 hour to 12 months, and in case of magnetic, you can go for minimum 1 day to 200 years. Really, okay, fair enough. Okay, so yeah, you can define your retention period, and then you create your table. So your table is ready. So your backend system is ready. Now we will create an IoT rule, which will simply take the messages from the device, and then we will publish it to the Timestream database. So in order to do so, we go back to our IoT Core console again, and then we say, I want to create a new role. And we give this role a nice name called Dojo IoT Rule. And then this rule says, okay, generally when you're defining a rule, you're saying that, okay, I want to read a message from somewhere. And as I mentioned earlier, that when you're using IoT Core and device communication, the communication is based on publish subscribe model, and the messages are published to topic. So we need to tell Dojo IoT Role a topic from where it will read the messages which are published from the device. And that topic in this case is IoT Dojo inbound. Okay, so we are saying that well, rule read all the messages from this particular topic. And again, you can provide certain filter criteria as well, but in this case we are keeping it pretty simple. We are saying that, hey, all the messages coming to IoT Dojo inbound rule, I'm interested in getting those messages. The rule, that's the rule configuration. So you say, okay, I'm interested to read from IoT Dojo inbound thing, and then say, okay, what do you do with the messages then? And say, well, I want to add an action. I want to do something with the messages. So click on the add action, and in that add action, you see a long list of things you can do. But go towards the bottom of the list, and you will see something called write a message to a Timestream table. So you select that option and say, I want to configure that action. And when you do so, it will open up this screen for you, where you can go and define which database you're going to store, which table you want to store. And then here you can provide more information about your dimension. So what happens, guys, is generally, this information actually, you can also send it. So again, dimension could be little, like sometimes you can also send a dimension information as a part of the measurement, as a measurement, not as a part of measurement, as a measurement, or sometimes you can configure dimension here. So here in this case, you're saying that, okay, I'm getting the messages from device 1, and then this device 1 is at the device site, which is factory 1. So I'm simply adding a device name and device site as a dimension, but yeah, you can configure it the way you see. And generally, in this case, we're saying this dimension is kind of a fixed dimension, where we're saying, okay, if the data is coming, this is the metadata I want to associate with my measurements. And if not, then I mean, of course, you can also publish any kind of device information as a part of the measurements as well. But if you think that you can add some dimensions, some metadata, here is the place where you can configure certain dimensions with your devices. And then at this point of time, you say, okay, fine, you want me to store data inside time series database. Which role will allow me to perform this action? And here we select this Dojo IoT rule, which we have created earlier in this step. And then, yeah, simply we add action and then click on the rule, and now the rule is ready. So now the rule is ready to read. So the way the flow will work is that the device will publish message to this Dojo inbound topic. This rule is reading messages from Dojo inbound topic and then storing inside your time series Timestream database. So now the time to test it. So let's go and publish some messages. And in order to publish these messages, we are going to use MQTT client simulator, which is part of AWS IoT Core. So we go to MQTT client as a part of IoT Core, and we click on the link called publish to a topic. And then here we simply provide the topic name as say Dojo IoT / Dojo inbound, and here is the message I'm providing. So if you look at this message, guys, basically I'm saying I'm providing 3 measurements here: temperature, vibration, and pressure. These 3 measurements we are providing. So you can add as much measurement as you want, but in this case, I'm taking the example of these 3 measurements, which the IoT is the device is providing, and we simply publish the message. And then, for the sake of testing, I just changed the message a bit more, and then I published another message. So I have published 2 messages over here with different set of values for temperature, vibration, and the pressure. And what will happen? These 2 messages get published to this topic Dojo inbound, and then my rule will pick up the message and will simply store that message inside Timestream database. So let's go and see that this data, and with this dimension, how does it store data inside? The dimension in the previous step. How does it store data inside Timestream data? So if you go to Timestream database, Timestream console again, you can open this Dojo table which you created earlier, and there you find a button called Query Table, which is an inbuilt query tool to query data. So if you click on the query table, and you run the simple SQL command saying, okay, select star from Dojo database Dojo table. Yeah, it looks like very much how you work with Athena actually. And then, it gives the same feeling. And then, when you run it, actually, you can see the query result, which shows, and you can see that how the information has been serialized. So each of this JSON document has different properties of fields. Those has been converted into measurement names, and their values has been converted into measurement value. Whatever dimension you have set up as a part of your IoT core to time series, as a part of your IoT action configuration, those dimension has been added as column, and whatever value you provided over there, those values are also provided over here. So you can see here, it has simply serialized the whole information into time series database table. And you are then good to go. You can then use this table to do different type of analytics query you want to perform on your time series data. So next step is that's where the integration actually completes. And next step is to simply go and clean up the resources so that you don't incur any cost. So that's where the workshop ends. I talked earlier that today I'm going to show you how does the AWS IoT Core to time series integration out of box look like. But I'm very interested to actually create another exercise where we will try to write some Python code to publish the data and also query the data. And I'm going to come back with that very soon. I think that will give ideas to know. I mean, because you might feel like, okay, fair enough, I'm able to store my data, but I really want to implement some business logic as a part of storing the data. In that case, you don't want to simply use the configuration, but you might want to write a lambda function which simply takes the value and then and then and then parsing the value and then storing into the time series data the way you want. So for that purpose, I will provide another exercise where I will show you how you can write say Python kind of code to publish the data to time series data database table and also query it. So stay tuned for that part. But yeah, that was all for today. And if you like the video, please click on the like button and please subscribe to my channel. It really encourages us to create more such videos. If you have any feedback or comments, yeah, feel free to provide us as a part of in the comment section of the YouTube channel, or you can also use this contact us button, a tab, and you can provide feedback over there. And if you, there are many other exercises and workshops similar to what we went through to implement different scenarios using AWS services and learn about AWS services. Yeah, so feel free to explore our website and yeah, use these different workshops and exercises to learn about AWS services. So that was all for today, guys. Hope you liked the video. Look forward to your comment. And stay tuned. I'm going to come. Yeah, I'm coming back with another video sometime very soon. Till then, have a nice day and stay healthy. Bye bye.